Hello everyone, hope you all are doing well. In this video, we'll discuss the second problem of biweekly contest 79. The problem name is sender with largest word count. It's a medium level problem. So the problem says that we have a chat log of n messages and we are given two string arrays, messages and senders, where messages of I is a message sent by sender of I. So yeah, the length of both will be equal. That for each index I, sender I has sent a message of I. Now it says what is a message. So a message is a list of words separated by a single space with no leading or trailing spaces. So yeah, just basic definition of message. And the word count of a sender is the total number of words sent by the sender. Now we need to note that a sender may send more than one message. So if a sender has sent multiple message, so for each message we need to count the number of words, and for all the messages we need to sum it. So we'll get the total number of words that the sender has sent. Now, what we need to do is that we need to return the sender with the largest word count. That means sum the number of words in all the messages sent by a particular sender and return the sender which has the largest word count. Now, if there is more than one sender with the largest word count, we return the one with lexicographically largest name. And yeah, it says that name can have both, and Alice are distinct. So yeah, it is case sensitive, it means to say. If we look into the example, so this is the messages array and this is the senders array. So we can see that there are four senders: Alice, user 2, user 3, and Alice. So if we count the number of words sent by Alice, so in the first message we have two words, and the last message is also sent by Alice. So in this we have three words. So the total number of words sent by Alice is 2 plus 3, 5. If we talk about user 2, so we have only two words in the message, and this is the only message sent by user 2. Similarly for user 3, we have just one message with three words. So the maximum number of words sent by a user is, in this case, is Alice, so we return Alice in this case. Again, if we move to the second example, so we see that we have Bob, we have Charlie, and we see that both have sent messages having five words, but it says that since there is a tie for the largest word count, we return the sender with lexicographically larger name. So in this case, obviously, if you sort Bob and Charlie, so Charlie comes afterwards, so that is lexicographically a larger name, so we return Charlie in this case. It tells about the constraints. I would say nothing fancy in this case, because as again implementation based question, we just need to probably for every user count the number of words and just return it. So it will be sort of a linear time complexity. So the algorithm is, I would say, fixed in this case. But again, it says that n can go up to 10 raised to the power 4. Message can have a length of 100, and senders length can go up to 10 and all that. All the words in messages are separated by single space. This is important so that when you split it, you know that okay, you don't have empty spaces, but all the valid words are present. So no need to understand with it with the help of a diagram. It's just sort of the question tells what we need to do. We just need to write the code for it. So we initialize a map, and we initialize a couple of variables, max, count, and answer. We have used this so that while we are calculating the number of words, at that time only we calculate the answer. Now we traverse the sender list, and we see whether the current sender is present in the map or not. That means, is the current sender, are we getting this current sender for the first time, or we have received a message from the sender previously as well. So this is for that. If it is not, if the sender is coming for the first time, we add it to the map. The name, like suppose we put Alice comma 0. That means Alice had total 0 words till now. Now the map is the work related to map is done here. We will always have a user when we come till here. Now we go to words. So what we do, we pick the current message. That means the message sent by the current user. We split it based on the space, and we get the words that are uh, present in this message. Now all we need to do is that we update our map. So we update our map by senders of I will now have the previous value for this sender. That means the previous word count for this sender plus the number of words that we have in the current message that we have calculated here. So this will be done, and we'll calculate that what is the final value for this particular sender. Suppose it is current count. So in this iteration only we'll calculate that if the current count is greater than the maximum count, maximum word count by a particular user. So what we'll do, we'll update the max count, and we'll update our answer. Ideally I should have taken the variable name as name, but again, since it was a contest, I was writing code pretty fast. So yeah, I've taken answer. Otherwise, a name variable would have been better here. So we update the answer. Now, in case of a tie, that means if the current count is equals the max count, so we compare it, which string is lexicographically larger. So we compare the senders of I dot compare to answer. So if this is greater than 0, that means we have a lexicographically greater string. So we update our answer and we finally return it in the form of our answer. So yeah, that's it. This is a big O of an implementation algorithm. We just run our loop one time, and the operations in a map can be considered to be a constant time. That means big O of one. So, and the only extra space that we have taken here is of map, which will take space equivalent to the number of distinct senders that we have. So yeah, that's it for this problem. And hope you learn something new. But though it's an implementation based question, but yeah, probably we don't need to run extra loop and we can just do it there itself. So yeah, and see you in the next video. Take care. Bye bye.